Welcome back, boys and girls. I apologize for the longer than usual waiting screen. Let's put up some music real quick here. Hold on. There we go. I apologize for the longer than usual waiting screen. As you can see, if you look at the bottom of your stream display right here, I'm still trying to install Torch. I said, oh man, I'm going to be actually prepared for a stream. Oh boy. You know, I got started like 45 minutes early. I got everything, you know, did a little research, got all the web scraping stuff out of the way, you know, all the stuff that would leave you guys waiting. You know, I tried to get it done before the stream, and then I tried to install Torch, and I'm still installing Torch. So, I'm not sure what we're gonna do while that goes. If I was smart, I would have... I mean, there's a couple things I could have done if I was smart, but I'm not. I'm not. So, let's see. It's saying we got about 6 minutes. What can we... Do we have a game that we can just kind of put on while we're... I don't want to leave you guys just sitting here watching nothing. What do I got? Let me look. I just downloaded Sid Meier's Alpha Centauri, but that's not gonna work. Man, I don't really have anything. Every game I play is the kind where, you know, it's not a game you can play for 6 minutes at a time, you know? Yeah, you want to pull up like an article? Let's see, what do I... do I have anything cool in my Substack subscriptions about software that you guys might want to have me read out to you? Not really. Okay. I'll tell you what we'll do. old.reddit.com/r/ We're not doing our jokes again, but we can do programming. See, clever algorithms, nature-inspired programming recipes. Okay. ISO 8583, the language of credit cards. That sounds cool. Okay. Let me zoom in on that and then switch to the browser. There we go. Okay. So let me move the PyCharm window so I can see when Torch is done. There we go, and move all the chat windows so I can see them. There we go. Okay. ISO 8583 is the standard for real-time messages communicated between acquirers and issuers through all of the major card networks. Whenever you tap your card at a point-of-sale device or click Purchase online, odds are it will eventually end up as an ISO 8583 message between the merchant's acquiring processor, the card network, and your bank's issuer processor. Early on, the point-of-sale device or the ATM might have built and sent the ISO 8583 message directly to the acquirer. But in today's e-commerce environment, messages typically pass from the merchant to a payment processor in higher-level formats such as JSON, which then in turn are translated to the card network's ISO 8583-based format, as opposed to the ISO 8583 cringe format. This approach simplifies the process by abstracting away the complexity of the ISO 8583 format from the rest of the payments ecosystem. When the standard was first defined in 1987, it included the overall structure of the message specification and the names and links of the core fields, such as the card number, primary account number, in field 2, and the transaction amount in field 4. The message began with a 4-digit message type indicator code, representing whether it was an authorization message, a reversal, or some other message type. This was followed by a bitmap that told the recipient which fields were present. It left room for a few fields that could be used by networks to include network-specific information. and as a result, the various card network specifications quickly diverged through a series of nested fields that did not overlap at all. Later versions of the standard greatly increased the number of fields, reducing the need for network-specific behavior for new implementations. Specifications like Visa's Base 1, or is that Base I, have thousands of clients running on everything from mainframes to devices like ATMs. However, making sweeping backwards incompatible changes next to impossible. Oh, I read that entirely wrong. Specifications like Base 1 have thousands of clients running on everything from mainframes to devices like ATMs, however, making sweeping backwards incompatible changes next to impossible. As a result, these specifications still largely follow the rules set forth by the original standard from 1987. Now it's installing Kublas again. You know, I wish I could install this stuff once and just use it going forward. The standard also allowed flexibility in how each field was serialized. For instance, networks could choose to use EBCDIC. I remember that, yeah. The 8-bit encoding scheme favored by mainframes for all fields, or opt for packed binary coded decimal to save space in numeric fields wherever possible. You know, looking back, why the fuck was binary coded decimal ever a thing? Why can't you just use the numbers raw, you know? That was the shit that gave us Y2K. That's why Y2K happened, because of fucking binary coded decimal. To save space in numeric fields wherever possible. This made the specifications defined by each network, such as Visa, MasterCard, and Discover, eventually evolve to have more differences than similarities. Throughout this article, we'll explore the basic structure of the ISO 8583 format before delving into its more complex nested subfields. In the end, we'll look at how you might define an ISO 8583 parser in code, grounded in how we process card transactions as an issuer processor connected directly to networks like VisaNet here at Increase. So, okay, they have this stuff specified as JSON, and then they gotta, like, I guess in order to talk to the fucking COBOL mainframes, they have, what was that IBM, really famous IBM mainframe? I forget the model number, but you have IBM mainframes from the 80s sitting at Visa, probably even the 70s, nah, probably the 80s, sitting at Visa headquarters processing this, these ISO 8583 messages. It's amazing to look back at how we handle data has changed. Like, just imagine how many more bits this is using to send this much actual information. And I mean, even this isn't particularly efficient. I mean, it probably is pretty efficient, but even so, you see there's more more data packed in there than, you know, what, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 16 times 13 bytes in there. Yeah, it looks like most of it is nulls. Okay, it's still installing CUDA stuff. I really should have installed these dependencies first. I didn't realize that adding, what was it that language transformers, because we're going to be doing some RAG today. And so I wanted to use a local embeddings provider. Maybe I shouldn't have done that. Because now oh god, is this even going to work when I try to run it? Okay, well, you know what? We can switch back while this is cooking. We can switch back to PyCharm and we can walk through. So what I did before stream, let's see if let me rearrange my windows real quick. What I did before stream, I pulled down the contents of the entire UFOpedia. There's some non-English text here. That's interesting. So you see the grav shield. General information. A grav shield doubles the potency of your offensive base defense systems, allowing each one to fire twice against an attacking UFO. Contrary to popular belief, the grav shield's abilities do not stack. Oh. Even I didn't know that. I thought they all worked. And then it has these tables here. Did it process these into Markdown? I'm not sure. I think... No, that doesn't look... That's not Markdown. That ain't Falco? No. So yeah, we have the X-COM Wiki. So as I was designing this before stream, I realized, since we're talking about the X-COM files, oh... Some of this is in languages other than English. Ooh, I didn't realize until just now. Okay, that's not a huge problem. In fact, because this is all getting processed by an LLM, it can... it doesn't care what language it's in. It'll just read it. As a matter of fact, sometimes there's information, I mean, it's pretty unlikely, but there might be information that's particular to each language, so we might actually get... Maybe. That's pretty unlikely. What am I thinking? Oh, so I would like to go through, because this is AI-generated code, actually, so I'm kind of reading this for the first time myself. Let me shrink this down. There we go. Yep, just downloading that Kudinin. I already have this installed. I don't know why we gotta download it again. Why is it downloading so slowly? Okay, we're not gonna worry about it. So we got the X-COM Wiki Scraper class, and it uses this this library called MW Client, and we got the Media Wiki Parser from Hell. That'll help us parse it. Those are the only dependencies for this scraper. So yeah, we just tell MW Client about this the UFOpedia site. The wiki is mounted at the root, and then I didn't want stuff from, you know, the re-release, not the re-release, the reboot. So we have these categories specified here, and then we have our relevant categories. We have a set for deduplication. And so for each category, we go set a category equals... So I believe that this, you know, it looks like you're just accessing a list. Actually, it may just pull this down. Listing.pagelist, self namespace 14. What the fuck? Oh, this is, namespace 14? Page list generator list. Oh, this is a little spicier than I thought it was. What the hell? Lazy loaded list of page... While the standard list class yields raw response data. The only question I wanted to ask was whether or not it... So, if you look at a MediaWiki site... let's flip back to the browser. I can actually... Ooh, don't show off my, my Gmail. Hold on, let me hide that real quick. You don't need to see that. Ooh, there's my API keys. You really don't need to see that, huh? Okay, here we go. If you look at a MediaWiki site, UFOpedia, there we go. So, and then you would go to ufopedia/api.php. Okay, it added all this crap, but whatever. You see they have a, oh, would this be a REST API? I guess it is. Kinda, not really. Oh yeah, it is, because this is a GET, yeah it is. But you can see you have this API.php, and you can hit this with whatever kind of request you want, I guess. Yeah, this is a REST API, yeah. Kinda. Is it really? Because I've been reading about this stuff, because I got asked about this stuff in an interview, and I'm like, I don't know. So I've had to study up on how some of this, the whole REST thing actually works. No, because if it was REST, it would be telling you, like, REST, if you're actually doing REST, that implies that it's kind of self-documenting. This is just giving you information, but I guess we did. Like, it doesn't tell you there should be actions specified in this response. In any case, you can hit this API.php thing to make queries over the wiki. So that's what we're using to scrape the wiki. Now, is it even really scraping if you're hitting the API? But this MW client tool makes that simpler. So we get the categories, self-site categories, category name. So we get the object that represents that category, turn it into a list, and then we know how many pages there are, and then we ignore talk, special file, and template pages. I wonder if we want to actually include talk pages, because sometimes when you're looking at, like, especially in Wikipedia, you know, the real gold is on the talk page. That's where you know, it's kind of like the Torah. There's the Torah, and then there's the commentary. I don't exactly know how it works, but there's the holy book, and then there's thousands of years of rabbis talking about the holy book and what it actually means. And sometimes the answer you want is in the commentary. Sometimes when you're dealing with wikis, the answer you want is on the talk page. But, yeah. So we filter these pages, and then we mark that we've seen it, and then we add it to pages to scrape. Well, that's interesting. Okay. And then flow pops up from here. And this is our main scrape function here, yep. So that, for all the categories we want to scrape, this gets all the pages. And then we start scraping, and then we just, we have a TQDM that pops up a nice little loading bar. And then we do get page data, and then we write it out to a JSON-L. And get page data, all it does is, what does it do? Yeah, it just pulls the information out of this page object. The AI added all these. Honestly, all I want is content. I kind of wish it had just omitted all this. Maybe keep the URL. And I guess last modified, because if you're designing a production RAG system, there's some value in being able to say, hey, this page was last updated at this date, and then the user can say, well, I'm asking about, do you not know about the thing that happened on this day? And the bot can be like, oh no, my information is from this date, sorry. But yeah, that's the entire scraper. It's pretty straightforward. And so, once our freaking requirements are installed, we have a llama index-based RAG system. So, I think if you've listened to my streams for a while, I've kind of put down these frameworks. I don't know. It's been my opinion, and maybe this is out of date, because kind of the last time I looked at this kind of stuff was over a year ago, and that's ancient history when it comes to AI. I've been kind of down on these frameworks. I would rather, for a real production application, there's always little shenanigans. I mean, because people think that a RAG system is just, you have your bot, and then you have, we'll scrape our internal wiki. We'll just dump a bunch of PDF documents we have lying around, and then it'll just magically work. You know, we just process them into a vector DB and magic happens and it just works. Well, no, because the answers to the questions you want probably aren't in your fucking internal wiki or whatever random PDF documents you found. So there's always stuff you want to do, and I think for this stream, assuming, you know, unless it takes 3 hours and these just never install, and I just have to yap for 2 hours, and that's okay. That's what most streamers do. We're just handling the UFO wiki, but because we're playing XCOM files, most of the information we want isn't on there. So I'm thinking I can get it to, because there's that trigram reactor thing that reads information from the actual, like it goes to the mod's Git page and reads the mod's rule files and actually scrapes the, like the data of the mod to present it. I was thinking we could give the bot access to that. I was doing some experiments with that, but it would take, you know, standard RAG is not going to work for that. You need to be a little bit more clever, and that's kind of been my experience is you need to be a little bit more clever. Like, vector databases don't magically just make the right thing appear. But in any case, so we got Llama Index. We're using ChromaDB for persistent vector database. And we're using Claude for our LLM. And we're going to be using BGE small en v1.5 for our embeddings. So you can see we pull my API key out of env. Do we have the... No, we don't. Okay, let's... While we're here, what the fuck? We're skipping that one. Some of these songs are weird. This is from the, Wait, can you guys even hear that? No, it's quiet, but it's there. I'll turn it up a little. There we go. This music is from Keygen Jukebox, which I don't think... Is Keygen Jukebox? Let me check. Keygen Jukebox. I don't think it is. I think it... Are they back? It's back! Oh, shit! It's changed, but it's back. Oh fuck. Keygen Jukebox is, was and now is again a website that played Keygen music. So back in the day, you would, I mean, even still, software comes with, when you buy a piece of software, it comes with an API key. Sort of like when you're installing Windows, I think Windows still asks for keys. I haven't touched Windows in a while. So these keys, you know, it's this 32 or 64 character string, and it has to follow certain rules, and if it follows certain rules, the installer accepts it and says, okay, you did actually pay for the software, congratulations, I'll install it. Well, people reverse engineer the installer and then create a piece of software that will generate a key for you, and that's called a keygen. And because of the way the hacker community at the time, well, they were called, what were they called? What were, oh no. What were people who made wares called? Shoot, my brain damage is acting up again. But yeah, it was kind of the way it was that you would put cool... Like, there was a lot of overlap with the demo scene. Ooh, let's pull up some demo scene stuff. That'll help us kill some time. There we go. Let's switch back to the browser. Ooh, actually, I don't want to show you that browser. Let's go here, YouTube. YouTube.com. Demo scene. Not demom scene. Yeah, the best demo scene PC demos of all time. Oh, that's Future Crew. There we go. browser. We'll switch to... Okay, which one? I have so many freaking windows open. Here it is. So the idea of the demo scene was to kind of show off, like push the boundaries of what you could do with computers at the time. This stuff started with like the Commodore 64, that era. And you know, the Commodore 64 had a lot of really tight limitations. So it was really impressive if you could get cool graphical effects out of it, and that created the demo scene, creating these really hard, you know, advanced programs to show off cool visual effects on computers of the time. You probably can't even hear me. Let's turn this down a little. But yeah, so, and yeah, as you can hear, so this is tracker music. So they would have these short clips of instruments, and then it would have the track that basically says, okay, pitch shift this instrument clip up and down and play it at this specific time, and that was how you made music on computers back in the day. So, you know, you can imagine the kind of people who spend their time removing the DRM from pieces of software, you know, oftentimes putting it up for free. They really looked up to these demo scene people, so these keygens would often have little demos of their own built into the keygen. So that's where this music comes from that I was playing earlier. Let me see. Just keep an eye on how this is installing. We'll just watch demos. Fuck it. You know, in the modern era, when we have, you know... Look at that. Yeah, that was crazy back in 1993. Here, can I add another window capture that just captures my... No, I don't know how to do that in OBS. Okay, now it's installing Parse. I didn't realize I was going to be installing this much crap. I'm really sorry about this. It's been 40 minutes now. Why is it going so slow? Whoa, look at that. That's really cool. This is around the time X-COM came out, isn't it? You know, I just realized I can't see my YouTube chat. If anyone is chatting on YouTube chat, I apologize, I can't see it. Yeah, running, I think that's an example of an affine transformation in that bubble. I think. That definitely is an affine transformation. That was some crazy stuff back in the day. Even now, if you're doing affine transformations every frame, that can start to chug if you're rendering on software, even on modern systems. Yeah, I think in future streams we're going to be doing some of this, some kind of similar stuff. I have some ideas in my ideas file. Doing visual effects like this. Doing stuff like this is how I got my first job. They're like, we need someone who knows how to do NumPy, and it's like, I did some stupid visual effects in NumPy, and they're like, you're hired. Let's see, what do we have any from... Yeah, this was before Doom came out. Yeah, it's still installing crap. God damn it. And should I just switch over to XCOM? Okay, if it's not done by the time this is over, I'm gonna have to end the stream and just continue this some other time. Look at that reflection. I mean, it's obviously not a reflection, they're just rendering it again. Maybe? I'm not sure. Look at that. Is that a chick riding a bear? Okay, it's almost done with NCCL. Man, look at that. No texture mapping, by the way. Okay, now it's installing the NVIDIA linker, but that's coming down pretty quick. Okay, I think we might be getting to the end here. Future crew. They've got nuts. You imagine being so early to the computer graphics scene that your handle can be pixel, you know? Now it's downloading Triton. What the hell? Okay, I think we're gonna have to call the stream here, because this is gonna take all day. Shoot, I feel really bad. I'm sorry, everybody. We're gonna have to... We're just gonna have to call it. Well, we are gonna continue this. Maybe we'll do it... What day is today? What day is today? Thursday. Maybe we can continue this Friday evening, or maybe Saturday. I don't want to screw you guys out of a stream. I think I can find some time on Saturday. Yeah. That's a cute joke. Alright, well, that was Second Reality. At least we watched a demo. Yeah, Finland in 1993. Oh yeah, those were, yeah, epic mega games there, yeah. Those are the people who make Unreal Engine now, after the Unreal games. Alright, well, yep. I'll see you again next time. Hopefully we'll actually be prepared next time. Thank you all for coming out.